5. Okay, everyone, I will wait for 1 more minute and then start, okay? So just as a reminder for the last couple people who just joined a second ago, to ask you to bring up an Earth Engine window, the one that you pasted information into yesterday. Bring that up on one side of your screen and make an empty tab on the other side of your screen. And what we will do, like what Rylan will do here in a few minutes, is we will click down there where it says Part 5 on EE 101. You'll click there on the document and open up that document. We will then go to step 16, I think it is. Okay, so before we do that, let's recap a little bit on what we did yesterday. So I'm just going to go through the outline of just what's here on the page, where it says Part 1, introducing the day. That was where we talked about Zoom and how the different parts work, how the interpretation works. Anybody should also still be able to see that interpretation icon on your screen. If you have any trouble with that, let us know. For part 2, who are we? Rylan in Africa and I talked about the work in my lab and the work that they have done and the work that they will do in the next couple of years. And then the third part, we reviewed who you are and the things that you have done and what you know already coming into the class. If you remember, most people had very little experience, just a little bit of experience with Earth Engine. So hopefully, if you said 2 yesterday, you would say 3 out of 5 today. And then part 4, we talked about what is Google Earth Engine. So the source of the data and also the computing platform. We then, with part 5, did the first 6 or so steps of Earth Engine 101. And we gave to you as an exercise for the sort of second half of the morning, the job of going through the rest of the steps up to step 16, and that's where we'll pick up now. So I'm going to turn it over to Africa. I'm going to ask, go ahead, Rylan, and click on the document. That's great. Thanks for pasting in the English document and the Spanish document are both in the chat. If anyone has trouble seeing getting there on your own, you can just click on what you see in the chat. Okay, and we'll go to section 16. And so while Africa gets ready to start explaining that, can you, whoever's hearing me, can you please type into the chat whether you are, yes, able to get to section 16? Okay, that's where we want to get to. Okay, that's great. All right, so if anybody, especially if anybody has trouble, write no in very big letters and we'll see if we can help you get there. Okay, great. So Africa, I will pass it to you. Go ahead and start them up.
Thank you so much, Jeff. Okay, let me share a screen, but first we will go through what we will do today. Can I share the screen? Thank you. We will. Okay. Here you can see my slides.
Yep, we can see them.
So weird. Okay. So for today, we are going to do all together an exercise in which we create a land cover map. And these are the general steps. And I'm just repeating them. I will repeat them several times because we will be doing this twice. Once all together, what we are doing right now, and then you will do it in small groups. This is what the script is going to do. We are going to select a country of interest. Then we are going to create a composite using Landsat 8 surface reflectance product. And we are going to create that mosaic, that composite, identifying specific characteristics for the composite, like we are going to use the pixel quality. And then we are going to collect training data using Google Earth Engine, in Google Earth Engine, and we are going to train the car model, which is classification and regression tree classification algorithm. And then we are going to apply that classifier to our composite image. It's a very simple script, and you are going to apply everything that you learned yesterday. So we are all going to open a new tab. I'm going to reset here so you can see. I think that you can see well. And also, as Jeff and Ryla mentioned, you will need to have open your document. This is the script that we are going to follow. So I think that yesterday you learned about image collection. Also, did you learn about feature collections? No, but right now we are going to work with feature collections as well. And in the GE, feature collections is like shapefiles that we are used to work in GIS. Yesterday, you also saw how to create a variable, dictionaries, and how to create a function and how to apply that function to an image collection. That's what we are going to use in this script. It's exactly the similar, just that apply for a particular purpose. So the first thing, we go to our script, we all have open Google Earth Engine, right? So we are going to use a feature collection that is available in Google Earth Engine. And if we go to our instructions, we can copy this name, lzip simple, and write it in the search window here. And this is a shapefile that contains international boundaries, all the countries. So you can see here, yesterday you imported this file or the way you accessed this information, it was by importing it. Another way that you can do the same thing is clicking in the file that you were looking for, or whether it's an image collection or a feature collection, and you can copy the code that is going to call that. So you just click here. And then we are going to create a variable called countries. And then you paste the code that you copy from the information in GE. So now we are calling this feature collection. And another thing, when you are here, you can also see some information about that feature collection. For example, it has these attributes, these fields, like the country, CO, country underscore NA, which contains the US recognized country name. So this field is the one that is going to contain the country information, the country name, and is using US recognized. And I don't know, maybe Jeff and Rylan can mention more, but in my experience with Google Earth Engine, Google Earth Engine is excellent at managing rasters. Everything that we are doing here is just requiring so much computational capacity, and we're processing so much information. But when it comes to shapefiles or feature collections, I think it's a different story, or at least from my experience. So now we are going to create another variable called country. And what we are going to do is we are going to select one particular country for this from this feature collection. And the way we are going to do that is by filtering the feature collection by the field country NA. And in this case, we are going to use Mexico. So you run this. So now you are selecting this this feature, this polygon from this feature collection. but that's everything that we have done, the only thing we have done. Now we are going to center our map to that location and to visualize that layer in our map viewer. So those are the other two lines here. And yesterday, if you can navigate through the map viewer, you know, to position your map wherever you want, or to have it in your code, you already put it here. So the way to do that is by map center object, and you write the country variable, and this is the zoom that at which you are going to see that. For any function that we are calling, that we are writing here, you can always go to docs and to see what are the arguments for that particular function that you are calling. So you know what it should include. So in this case, is map center object, and this is just going to position our viewer in that location. And then we are going to add that shapefile, which is for Mexico, in our viewer. So we are going to add map add layer, country, and we can leave this by default, or we can add a color. We are going to add this color. And this is just going to add the shapefile to. And now in our layers, we should have this. We can add a name as well. And now the layer has a name here in our viewer. Okay. So now we have selected our area of interest in a way. The second step will be to create our image composite. We are going to do this in a more dynamic way. We are going to create the composite for 1 year. So we are going to do this in several steps. First, we are going to define our time frame for which we are going to create this composite. So we can write some lines of code here to do that. We are going to create a variable called year, and you can include any year of your interest here. I'm going to include 2019. Then I'm going to create another variable called a start date. And it's going to take into account the first variable, my year, but I'm not going to write 2019. I'm going to call the variable year. Plus, and I'm going to include the beginning of the year, January 1st, and I'm going to create another variable for end date. I'm going to take the year, and I'm going to put it to the end of the year, December 31. So with this, once you revisit the code, you can only change here the year. You can do it for any years of your interest, and you will just change that, and it will go from the beginning to the end. If you want to see how that works, you can print the start date. So, oh, you see, and I always like to print because I realize that I have errors. We have to have this guion. Okay. So now that you have selected the time frame, we are going to create a function to mask the clouds. Well, obviously, first we have to call our collection. We are going to use Landsat 8 data. So if we go here to the search, we can start writing Landsat 8 surface reflectance. And you're going to see all these different products. We are going to use Landsat 8 surface reflectance tier 1. You can click on this and it's going to give you information about that particular data set. Here is the collection snippet. This is the code that we can copy and paste in our script. But before we do that, I just want you to see the metadata of this information because it's key. It depends upon what type of data set we are using that we are going to manage that information in our script. So we have to be familiar with that. So first, this is, well, Landsat 8. I think that maybe all of you are aware of the information at the different spectral bands that it contains, but it's always good to revisit because different sensors have bands in different positions. So we can remember, okay, I know that band 1 is the ultra blue and it covers this part of the electromagnetic spectrum. The data is a scale, and if I want to descale, I will need to apply this factor that is over here. And it contains all these spectral bands, and it also has a pixel quality, which indicates the bits. And this is useful information because we are going to use it later to mask the clouds and the cloud shadow. So we can see that in this pixel quality information, bit 3 contains cloud shadow and the bit 5 contains the cloud. And you know, actually this is important because I was checking for Landsat 8, this same exact information, but because there are different tiers, different type of products, I may have been checking a different one in which the quality pixel may have been termed differently. And I was finding that the information about cloud and cloud shadow were in different bits. And I was all confused. So that's why it's very important. And I don't know why I was doing that because I should have gone to the source of the information that I actually calling to make sure that I am looking at the right metadata of my information, of the particular information that I'm using. Then I also want you to check the image properties. So this is at the image level. We have these parameters like cloud cover land, and we can also use this information when we are filtering the data, which is what we are going to use or do. And I have been getting this script error for, I don't know if Rylan knows what is this. Like, right now I don't have any error in my script, but I don't know what it, since yesterday I have been getting that. I don't know, something with my browser.
I can't see why that would be. I don't think there's any real error in your work. So I would just go on past that. If you,
Yes.
I think if you click on the number 25, it's saying there are 25 errors. So it could be something like maybe the different borders have some little errors in them and it's seeing that there are little inconsistencies. It could be something like that, but I don't think it's anything with what you're actually doing here. So I think it's okay.
And well, I just want to tell you a short story about my experience with the shapefiles in GE. And is that some years ago, not that many years ago, but some years ago, GE was still new, a little bit. And I was trying to use an analysis using a shapefile from USGS for basins. And we are going to create, we are going to create a variable called Landsat 8 here, and we are going to paste our snippet from that collection, or cut snippet. So now we are calling this. But just briefly, so I was trying to use a shapefile from the USGS for basins, which is humongous. And I already clipped it just from the southeast, but it had way too many vertices. And I think there is a limit in GE for how many vertices you can use in your feature collection. And this was a very weird shapefile because it had some polygons that were very big at the administrative level. You know, there were like thousands of square kilometers, and then it has some polygons that were like 1 meter by 1 meter. It was just crazy. And I needed to do a special analysis using MODIS data with that shapefile. First, I had to fix it I tried to do it in QGIS, it didn't work. I have to do it in ArcGIS because the shapefile wasn't completely closed. You know, there are some projection errors sometimes with your shapefiles. And then actually, that was the first time I heard about Nick Clinton because he wrote me that I was killing GE. So that just shows. I said that I am an air system scientist. I use programming. I'm not a programmer by default. I have learned to do it because we had to do it in air system sciences. But I was doing something wrong in GE, and I am used to geospatial analysis, and I was like, this is very simple. I don't know what is not working here. And I was just killing it. It was just my shapefile. So hopefully I don't do it again. But that's the, now we have called our collection, and now we are going to create a function to mask out the clouds. I also want you to actually you go to this collection and open the information in a different tab. And once you are reading to the description of this particular image collection, you can go down, and they have sometimes some examples about a script, and they already give you a function to mask out the clouds from Landsat 8, which is based on the quality pixel that I was mentioning before. So here we are creating a variable for the cloud shadow bit mask, which is selecting the bit 3. And we are also creating another variable to cloud the mask, which is selecting the bit 5. And why we are doing this? Because those 2 bits contain that type of information. So we can literally just copy this and go back to our script and paste it. And this is something that I do a lot in GE. And I think it's very nice that it's a very large community that is generating scripts and processes that you can build upon as well. It's extremely useful, but it's also useful to understand what is happening here. So here we are creating those 2 variables that I already mentioned. Then we select the band that contains the quality pixel information, and this name, we can check it in the information for that particular data set. And then we set those to 0 because when we have 0 is where there are no clouds. And we create a mask with that. Let me see. And that's created just as a function. So now we can apply that function to our image collection. Our next step will be to actually build the mosaic. So we are going to create a variable called, let me see how I call it here. It was Landsat A composite mask. Landsat A composite mask. And we are going to call our image collection, which is L8. Let me check. And we are going to filter, we are going to apply several filters to this. Right now, this LA contains an image collection with all the Landsat 8 information, everything. The first thing we are going to do is filter by bounds. And we are going to filter by country. We already created a variable that is called country. And we are going to keep applying filters to further refine this. So now for all the availability of Landsat 8, we are just focusing on Mexico. And we are going to apply another filter for the date. And for each of these functions that I'm calling, like filter bounds, filter date, you can always go back here and write like filtered, check what type of filters are. And we are working in an image collection. So you will go and focus on the image collection and see here, filter bounds, filter date. And you can see the arguments. I have to have an start and end argument. So I already create those variables. We have the start date and the end date. I'm going to keep filtering, and now I'm going to do it by metadata, I think, to select only the images that have less than 50% cloud cover. So let me do this. So for this, we have to call an property of the image, and we have the cloud cover. How do I know that we have this? We saw it in the properties of our image. Cloud cover and less than. And how do I know like which arguments or in which form I include this condition? You can go to this particular filter metadata to see the arguments, less than and 50. You can change this, you can put 30, 20, 80, and this is working at the image level. Then we are going to keep filtering. Let me see. Well, now we are going to map the function that we use, that we just created to mask the clouds. Which is this one, the mask LA surface reflectance. And this is working at the pixel level, and is going to mask all those pixels that have clouds. And the next one, we are going to use the median of all the stacks that are remaining here, the median value. And then we are going to clip it by the country. Yeah. Yes. Let me see, my syntax is fine. Yeah. This is where I have a lot of errors on syntax. So this is how we built our composite using the information from that image collection. The next thing that we can do, we are going to create a dictionary to create some visualization parameters, because now we have created our composite and we would like to visualize that composite. And in order to have some nice colors that we can interpret with our eyes, we are going to create this dictionary that is going to contain the visualization parameters. So we can, I think I give it Landsat 8. We are going to create a false color visualization, 754. And I'm sorry. Are there any questions so far? Oh, yeah. Se recomienda reportar por country con un área buffer de al menos 200 metros para Americana Costa, el borde para nuestro actualizado para América hacia las 10. Okay. So, C. Meneses I don't know if it's Carlos. It's just mentioning that it is recommended to use a shapefile that has a buffer of 200 meters along the coast. And that's fine. And you know, this is just an exercise and you can modify that shapefile. Actually, you can create your own shapefile in ArcGIS or in any other platform that you may have and upload it in the Google Earth engine and use it as the one to clip the mosaic. And there is also, okay, I'm going to move a little bit faster so we stay on time because then you will need to do this as well. So I'm just going to copy these visualization parameters. Let me see. You can just copy this. And then we are going to add that layer and use that visualization parameters. Let me, oh. Okay. This line is just creating the country name, is just extracting the information from the feature collection to put in the country name. And then here we are using just the map at layer and we are going to run this. And this may take some time at first, but it's going to create our oh, let me see, start.
Yeah.
Okay.
So
I wrote something.
if you go to line 29, you'll see it says start date. There's just a missing letter.
Yeah.
On line 29, I think it is.
Yes, correct. There it is. And now you have your mosaic. So just think about like creating a mosaic like this using the normal methods. It will take forever. And you can create this same visualization using RGB bands, which will be 4, 3, and 2. But for the purposes of this exercise, we just keep it like that. And we keep moving to create our training data. So I already have some training data in a previous script, but I want to go with you to do it because you will need to do it for your small group exercise. So you can zoom in a particular area in Mexico. I am from Guatemala, and I am from here, from Retaluleu. So I am from an area that is very close to the border with Mexico, and in Chiapas, which is here, has a very similar ecosystem that the one in Retaluleu. Is hot, humid, like hell. So I feel comfortable saying what is forest in Guatemala, and I feel comfortable saying what is forest in this particular area of Mexico. So this is what we are going to do. We are going to use our geometric tools here. And first we are going to select in draw a rectangle. You click there, go to the geometry that appears here, and in this symbol, where it appears edit layer properties, just click there and we are going to change the name. We are only going to work with 2 classes, forest, no forest, and water. So we can rename this with forest. Instead of geometry, it's going to be a feature collection. In properties, you click the plus symbol and here you write label. You can write any other thing here, but for this exercise, we're going to write label. So we are all doing the same. And this is like the column that is going to contain our properties for this shapefile. And in value, we're going to write 1. Yeah. And we can select a color. This is going to be forest, that represents forest. So green, like this green. Okay. And now in your viewer here, you can start selecting those areas that you think are forest. So I'm just zooming here. In that this is forest, this is tropical rainy forest. You here, and with the hand you can move around, and please be mindful of the size of the polygons that you are selecting, because actually you can select very large polygons if you are a zoom level, you are very zoom out, and you're going just to kill Google Earth Engine when it's trying to do the classification, because you are going to have way too many samples, too many pixels. So just work at a zoom level where you actually can interpret the surface land cover. So these are going to be my polygons for forest. Now we are going to create the feature collection for no forest. So we do the same, we click in add new layer, then you go to edit the properties of that new one, and we are going to call it no forest. Instead of geometry, it's a feature collection. We add property, label, and this is going to be number 2. So everything that is collected as no forest is going to be is going to have a value of 2. Then, oh, I didn't change the color. If you want to change the color, usually just like yellow for no forest. Okay, so now you can go and to your map and select those areas that you think there are no forest. And of course, when you are doing this, you have to have a sampling design, know at least how many samples you will need to have for this. And we are doing this just as an exercise to see how you can use Google Earth Engine to do this type of analysis. This is not a throughout land cover mapping exercise. It just gives you the tools and know how to do it then. And imagine for all Mexico, you will have to go through the whole country and have a good representation of the different biomass and ecosystems that you have present in the country. So this is just a representation. This is not for us. Right? If you think that you misclassified something, or it was too big, or it was too small, you can close here, click here in exit. Sorry. And select the polygon and delete it. Okay, so now we are going to create the other feature collection. So you go back here and create a new layer. You go to the properties, and this is going to be water, feature collection, property label, and it's going to have the value of 3. And we can navigate through what is water. Let's see, yeah, this is water. Oh, and you can change the color. You can always go back and select something blue that is more water. Okay. You can start selecting here some polygons. There. Okay. This is just a representation. Is by no means a good, this is just an exercise, is by no means a good representation of the collection of training data to train a model, because we will need more samples for sure that represent the variety of landscapes that we have in an area. But we are going to leave it like that. So now we have 3 feature collections. They should have appeared on the top of your script here. We have forest, no forest, and water. And now we are going to merge those collections. So we have only one feature collection that contains all that information, all of our training data. So I think that we create a variable called training. Is that correct? Yeah. And we are going to merge. So this process is very similar to what you will do in ArcGIS. So in a way, I come from that school of ArcGIS. And you're going to start merging your classes. So we have no forest, and make sure to use the same nomenclature, the same names that you use to create your feature collections are the ones that you have to use here. And then you're also going to merge the water. So I think in the exercise I put some uppercase, but here I don't have it, so that's. Yeah. And and now that's going to create one feature collection that is going to contain everything. Another thing that I will recommend you to do now is to save your script. I'm going to put a land cover, Mexico. Okay. So now we have collected our training data. That was nice, that was easy. And now we are going to start to train or all the steps to work with our model. And the first thing that we are going to do is to select the bands that are going to be used for this classification. So we can go here to our script, and we are going to create a variable called bands to use. Not that much imagination with the name, but it's useful to have names that represent actually what we are doing. And we are going to use the bands, the different bands that we have available in our mosaic, which are the Landsat 8 bands. So I'm just going to copy this. We are going to use bands from 2 to 7. There. Okay. And then we are going to train our model. Oh, I'm sorry. Before we can even train our model, we will need to create this feature collection that contains the spectral information for those samples that we just collected. Right now, we have a shapefile that has all these polygons, and some represent waters, other forests, and other no forests. And now we have to assign the spectral information that intersects those same polygons. So we are going to use that information to train our model. In order to do that, we are going to this part of the script. We're going to use this or this snippet. And I'm just going to walk you through what this is doing. So we are creating a variable called samples, and we are using our composite that we just created above, the one that we are visualizing here in the false color. And we are going to select the ones to use, this, and we are going to sample by regions. This sample by regions is the function that is going to allow us to assign this spectral information to this feature collection. So if you want to see what sample by regions does, you can write here, and it's working on an image, yeah, which is our mosaic, and it converts each pixel of an image that intersects one or more regions of to a feature. And the output is going to contain all the property per band of that input image, as well as the properties of the feature collection or that we are using to sample. So, and then these are the arguments. So we have to include the collection is our training data that we just created here. The properties is the label where we have 1, 2, and 3. and we put this name when we were creating our training data. The scale, we are going to use the lens at 30 meters. And then we are creating a random column that's going to be used later, not in this particular exercise, but if you want to do more analysis and you want to split the sample data set to do some training and then to do some validation, you can do that with that. So we are going to leave it there. So this is what we are doing in this, when we are creating these samples variable. And next we are going to, if you want to know how many samples you collected, we're going to copy this. We are going to print the samples and count all the everything. We're going to do that. So just want you to see that we collected polygons, but then actually we are working at the pixel level. So you're going to have a good number of samples. That doesn't mean that they're good samples because there were very few. They're not representing everything. That's also my point here. I have 2018 pixels that have information that we know they are forest or water or no forest, and they have assigned the spectral information as well. Well, now we are going to start working with the cart model. And first we have to train it. To do that, it's going to be very simple. You already have all the pieces. We are going to create a variable called land cover labels, which contain the label, which is referring to the same label that we created in our feature collection for the training data. And then we can write this. We are created trained cart. And to train that, we are going to use the EE classifier cart. You can check here for cart. There used to be a previous way of how to name it, but it's deprecated, and now we use the smile cart, ee.classifier smile cart. And for more information about the model and how it works, these models have been around for quite some time, and this is the reference. And it's actually not that old. It's actually younger than me, just 1 year younger than me. So it looks very young, but actually all these scripts are based on models that had been available for quite a while. So this is how you call it, the EE classifier smile cart. And then you are going to train it. You have to include the features. You're going to use the samples that were created just above and the land cover labels that is going to contain is the input property. You are just calling the input property for the samples collection, and the values, the spectral information that you are going to use to train the model. This is the bands to use. In addition to these bands, you could also calculate some indices and include them here and use those indices as well in your classification. For this exercise, we are just going to use the direct bands as they come. Let me just do that. Okay, we're going to do that. And then you apply that classifier to our composite. So we are going to create a variable called classify cart. We are going to call our composite. We are going to select the bands and then just classify, and we are going to call the train cart. And just with this line, look at that, We are going to classify our mosaic with that information. And the last step will be to visualize our classified results. And to do that, we are going to, I'm just going to copy this because we want you to repeat this exercise with your own information. We are going to map add the layer to our visualization here. The final result is going to be this classified card. And we know that it's only going to have 3 values because those are the values that we collected in our training data. So it's only going to do the classification based on that training. So our minimum value is 1 and the maximum is 3. And then we can assign colors, and this had been predefined. This is a green one, and now forest is like orange, and water is blue. And we are going to give it a name at the end. So we can run this at this point. Okay. Yeah. And it's going to take a little bit. But it's starting to load. So this process, maybe you have already done it using MB or any other software. Even I think that now in ArcGIS there's some capabilities to do land cover classification. You can do it in a very few lines here in Google Earth Engine. And we just wanted to show you the different things that can be done. And for you to replicate back at home. And in fact, right now, as the second part of the exercise, you will need to do this for your own country. So we can zoom in here. And obviously you can navigate. You're going to see that it's not that perfect, but it's not that bad either, actually. I'm surprised. Let me see here. It takes some time. But bear in mind, we are working with a whole, well, from the very beginning, a whole year of data. We create a composite that was cloud-free. And then we selected some training data and classified that composite image using the car model based on that training data. Water, which is, you say it's not that bad. Forest, I don't know, I wouldn't trust it that well. You can see that there are a lot of pixels, and I know that there is a lot of dry forest in Mexico that wasn't captured here, that most likely may not mapping as forest because that wasn't our representative sample. But yeah, so when you do this for your country of interest, we want you to navigate through the results and discuss them. Maybe have some already insights of what worked, what didn't work, and what would you change. Most likely more sample data sets because we have limited time, so we don't have that much time to be collecting a good training data set. But you know, just like that, in a few minutes, you created a land cover map for a whole country. That's just, we couldn't do this a few years ago. Look at that. Okay, so I'm going to stop here. And just to go through the script, the only things that you will need to change when you do this in small groups will be the country of interest and the training data. The training data you will need to collect. So you can delete the training data sets that are here. There is a trash can next to each. You can delete those because maybe you want to do this for Costa Rica or for the Zambia or any other country. So you can delete those training data sets there. Yes, Jeff?
Yep, no, it's great. Keep going.
Okay. No, I think maybe, do you have any questions at this point? And you can speak up or use the chat, but maybe better if you speak. And it doesn't matter, it can be English or Spanish.
No, it looks like there's a few small questions in the chat that are sort of technical questions, which we can help fix. And then when we break into groups, also you'll get a chance to talk about those confusing parts with the other people in the group as well. I might have stepped on somebody's question. Did somebody want to ask a question?
Hey, Jeff, this is Rupesh. Can I quickly ask, I posted the error that I got and you suggested about the typing label. I think I typed, but what is a good way to go back and fix it? Do I have to redraw those polygons and do do all steps from the beginning, or can I just go and fix it if something is missing? And how do we check it?
You know, I've never seen that exact problem before. So I think I really like deleting things and starting again. So
I can answer this one.
Great.
If you go in the map to the geometry imports icon in the top left corner of the map, your 3 layers should be there. If you click on the gear icon, edit layer properties, and that opens up. For each of your layers, you should import them as a feature collection, not as geometry. Then it should give you the option to add a property. With the plus button, press that, set the property label to label, and then the value to 1, 2, or 3, depending on which one it is.
Okay. Yeah, I'm just checking those and I think I did it, but I must have done some error. I'll have to recheck, but it could be 0, 1, 2 or 0, 1, 3. Does it matter?
I don't think that the exact value should matter.
No, for the value here, yeah, it doesn't matter. Yeah. So it's just for you to know that if you, for example, you are working with water, you give it the value of 0, that you know that 0 represents water. If you give it the value of 1, you know that that 1 represents that particular land cover type. It's just that.
And that thing of importing as a feature collection, maybe that is the that's a different thing that it would be easy to miss, that I heard Ryland say, import as feature collection rather than import as geometry. If that matters, that might be an easy thing to miss.
Yeah, I did that. I checked it, so it must be some other error. I did all of the 3 labels, and then the values are different. They are all imported as feature collection. Does it also matter whether W is caps, or if it's a small case, lowercase, or does it matter if it's changed? Because in the code it may be different.
Yeah. So for example, here when I did it, here I put lowercase, but I think that in the script is with uppercase. So here, when you have to call it with the same exact letters that you name it in your script. So here I use lowercase because my feature collection has lowercase. If I put here uppercase, when I call it here, it has to be uppercase too.
Okay. And so can I also, sorry to just take one more thing, can I also just change it right where you had selected it earlier in line 29, or where you probably moved now, but where it was saying, yeah, you had selected water on the top somewhere where it added. Like
yes, you can also change it from there. Yeah, the name, yes.
Yeah, right here.
You can change it here, or you can go to the gear bottom here that Ryland was mentioning. And you can also change it from here. You see it's changed now there. Yeah.
Okay, wonderful. Thank you. Thanks.
Yeah. So Africa or Ryland, can you talk about importing shapefiles? I'm thinking that's maybe what that is. You can probably interpret that much better than me, but maybe answer that one from Cesar.
Let me see. And oh, finally. I was having troubles getting. If we have base de datos de entrenamiento en puntos o polígonos, ¿cómo podemos incluir allí back? Yes, you can upload the shapefiles or the training data to GE. So you will do that in assets. So you can go to your assets here and add the, you see, I have multiple folders here. And I did something with my Google Engine account where I connected to the cloud. So that's why it's this weird Sentinel one thing here. I'm already working on a cloud project, but you can add here. You see, you have the options of shapefiles or CSV and image upload or table upload. So if yours is a shapefile, you can zip it or to just upload it from here. And here you can select your file and navigate through your computer and upload that. And then once it's included in your assets, you can go to your script and call it from here. Does that?
Yeah, I think so.
Yeah, okay. So let me see the schedule. You have 30 minutes, so maybe we can go to the breakout rooms now.
Yep, I think that's great. I moved the schedule a little bit to match where we are. So I have us from the small group analysis from 9 to 10:30. So that's right about now. It's great. So we are, if I remember right, we're going to ask Monica to break us into randomly selected groups of 3 to 4 people.
Okay.
Okay, Monica.
Yes, I'm on that.
So that'll be.
Yeah, we will have 9 rooms with 3 and 4 participants per room. I'm going to do it randomly, as you say right now.
Yep. And before you do it, let me say one more thing. So if you go into a room, we're going to push everyone into a room. That's what happens first. So you will disappear from this main room and you'll go into a group where you'll be there with 3 or 4 other people. I know that some of you have a specific person who you want to work with for this project. So what you should do there is go down to the lower right, I think it is, and you say leave the room. And leaving the room will then bring you back to the main group. When you're back at the main group, we can then push you into another room.
Yes.
Okay, so Monica, maybe you should make 2 more than that, I think, or something.
If I do 11.
But I think it's
11
but it's going to put somebody in every room or something. Yeah. I'm trying to think of how to make 2 empty rooms. I'm not sure that that's possible to do.
Let me see. No, it doesn't let me here.
Yeah, I don't think so.
So we can have 14 rooms with 2 or 3 participants per room.
No, let's do the 12.
Okay.
11 or 12, like you said. And then anybody who doesn't really fit in their room, come back and we'll figure out something somewhere for you to go.
Yes, to Rupesh, yes, sure. Like Jeff said, you can join a group that's Spanish speakers or English speakers, and also have your requests Rich and Rupesh. Let's go to the breakout rooms. Like Jeff said, go back to the main room if you are not pleased with the group that you are, and we move you around. Thank you.
Okay.
Let's go. Okay.
Okay, so you should see a note that says the host is inviting you to join breakout room, whichever one it is. And when you click there, you should go. If you don't see that message, type it in the chat to say, I don't see that message. Okay. So that seems to be going okay. So we can see, Monica, you can see the number of participants going down, I think. At least I've seen that before. And so that refers to however many people are left here in our space.
Yeah. In the participants, we have 12. So people are moving, are going 11 now.
Yeah, it's kind of fun to see that happen. So if somewhere in your breakout room box, you can see the names of people, and some of them are like in gray. If you see that.
Yes.
As the people go into the rooms, they sort of get colored to be normal color or grayed out if they're not there yet.
Mm-hmm. I have breakout room, 2 people speaking Spanish. I don't see anybody asking. Okay.
So what I'm hoping is Rich and Rupesh will come back.
Yes.
Then you can find a room, find 2 rooms that have 2 people in them.
Yes.
And then we go in and ask those people to go to the other room. Or I think that you can click assign them to, and you then push them into that other room. It's a little pushy, but I think you can control that to make that happen.
I can see Rupesh. Where is? I'm gonna take out Rupesh. Where is? Can you see Rich? I don't. Rich.
Okay, so the others who are here, while Monica is looking at that, so I have Leonardo and John and a few others. Do you have somewhere to go? Do you have a message saying where to go? You can either say it out loud or type it into the box. Bebe, that's, oh, okay, he's away from his desk, that's fine.
Okay, I have Rich and Rupesh in the same group, breakout room 6.
Excellent. Good job, that's great.
And now, but John, okay. Let's, Spanish speaker, more. Okay, I have 10 participants in the main room that are not joined the breakout.
Okay.
Should we ask them where do they want to go? Or
see if you can push them. I can't remember exactly.
when I press on them, okay, yes, I can put them in waiting room. No, I cannot. I don't have an option to put them in a breakout room.
Okay. Well, at least, you know what, at least one of them is like away from the desk, and so the others might be away from the desk too. So we'll just wait till they come back, and then you can do that. One thing that I did once was, I see what you mean, you couldn't push them,
No.
but what you can do is you can send them a request for some other breakout room, and then they go into that room, and then you can push them into the room that you really mean. So you need to, like, you'll generate another box on their screen. Some people don't see the box when it happens.
Mm-hmm. Now, Rupesh and
Yeah, Monica, could you place Rupesh and I in breakout room 11? We were there with Paul Berkowitz, and I thought we could do a Pacific Island all together because that's the region we're all sort of from.
Okay.
Please. Thank you.
11. How do I do that? Join. Putting waiting room. No, admit. Yes.
Yeah.
I don't know how to, they are in the participants, but I don't know how to add them back to a breakout room. How do I invite them to join breakout room 11?
Is their name in the top of the list of all of the people? You should have, I think, the names of everyone who isn't assigned to a room should be all the way at the top. Is that true?
Yeah, they are in the participants main room. Their names are there.
Okay. And can you right click on them or anything?
Yeah, when I click more, I don't have chat, as to video, make a host, co-host, allow, but not to put them in a room.
Oh, shoot. I'll Google for that. I just can't remember.
I'm trying to,
And because it isn't clear.
yeah. Give us a second, Rupesh, Rick.
No worries. Take your time. I'm trying to start working in the background, so no worries. Thanks.
Okay, thanks.
Rich, you can also start working. Then we would have made some progress with Philippines as the country of choice, if that's okay.
Okay. Yeah, I was just WhatsApping you.
Oh. Thanks, Rylan, again, for finding the typos. That's what we need, I think, for this one.
I had that issue too, Rupesh. I noticed I was cutting and pasting what Africa was typing. No, not what Africa was typing, but I was cutting and pasting from the docs export. And then I noticed that it wasn't matching what was in the Google Doc that has the code in it.
Yeah. And then when I typed label, that's where I messed up. I used uppercase L for label. It should be. So best is to just always keep using lowercase. Don't ever use uppercase if that makes it easier.
You know what? I thought it was at uppercase. That's funny. That's great.
I did the exact
little
same
thing, you know?
Yeah.
I did the exact same thing. Rupesh, I think we've worked together for too long because we're making the same mistakes.
So Rich and Rupesh, oh, what happened with Rich? Oh, there he is. I'm sorry.
Yeah.
Would you go to work with Paul Berkowitz? He stay in the room.
Sure.
Now
it's
alone.
We are trying to go there. It's just
yes,
not
that'd be
so
great.
easy.
Okay. Oh, but you can, but you have to be assigned, right? I can only.
Can you assign yourself to a breakout room? With some versions of Zoom you can, and some you can't. Depends on your.
But it said, yeah, you're supposed to be joining group. You are in breakout room 11. I can move you. I don't know if you can move yourself, but where do you want to go?
It doesn't matter. I know Paul, it'd be great to work with Paul. He's in there by himself, or Rupesh and I. Whatever easier for you.
So Monica, when you see the names of the people who are still here in this room, What do you see near their name in the breakout rooms window?
I see ask to unmute and more.
Okay, and how about more? What does it say under there?
I have options to put them on chat, stop video, spotlight video, make them host, co-host, allow to record, rename, put in waiting room, remove, or report.
Well, let's try putting in waiting room.
Okay. I'm going to try with Rick.
Okay.
I'm going to put in waiting room. Okay. And then I have the option of remove or admit.
Let's see admit.
Okay. He's joining. Okay.
So maybe do you get a new option?
No.
Yeah, imagine doing this with 90 students. That's kind of what my crisis is when I do it. I hate it. I hate it.
Yeah, sorry. Okay, I'm assigning.
No, you're doing great. You're doing great.
People are asking me to move them to the different rooms. So I'm trying to, or maybe we should.
It's our fault because we requested that. Sorry to
No.
confusion.
Jeff, you need to write a script for that.
I would love to.
Marilyn and Indiana. Marilyn.
Oh, and we can pause the recording now, whoever's in charge of the recording. Okay, and we resume the recording. That seems good, right?
Yes.
Okay, so Rylan, if you could share your screen, I see that coming, that's great. Okay, so hello everyone, welcome back. I hope you had a good time. It was a little rushed, of course, but the idea here was for you to get some experience actually doing this and really to discover the limitations and to see what the challenges are for doing a really good job with land cover classification. And I think for me also to make it clear to me how hard it is to make a good land cover classification, and for me to respect the land cover classifications that I see, that I just download. It takes 2 minutes to download some land cover classification, but it's easy to miss the months and months, maybe years of work in really creating something that we can rely on. So what we want to do now is for the next few minutes, we're going to go through each of your little projects. We don't expect that anything worked. So we're curious about what was easy, what was hard, what worked and what didn't work, and to tell us what you learned. We want to spend not more than 5 minutes on each one. So let's go to breakout room 1 and we'll start, and I'll start a little clock here to the side. Okay, go ahead there, Norma and Carmen and Rafael and Guillermo.
Hola, aquí Rafael. ¿Me escuchan bien? Sí. Estoy en el canal correcto. Perfecto. El grupo 1 somos nosotros, Norma, Carmen, Rafael y Guillermo. Aquí tenemos una foto muy pequeñita en la parte de abajo. Y pusimos las banderas de los países desde donde estamos hoy. Costa Rica, Ecuador y México. Un gusto saludarlos a todos. Trabajamos en un mapa de cobertura de Costa Rica, utilizando el script que vimos en la clase con para el año 2019, filtrando por la nubosidad. Costa Rica es un país bastante nuboso, inclusive van a ver aquí aspectos que es difícil corregir el tema de las nubes. Las clasificaciones bosque, no bosque y agua, y seleccionamos varias áreas de entrenamiento para estas categorías. Funcionó bien la parte de bosque, aunque hubo algunas confusiones, y para eso hicimos un pequeño análisis rápido utilizando información sobre palma africana en la zona sur de Costa Rica, esta parte de aquí en la zona sur, en donde estábamos tratando de ver si se había capturado algunos polígonos como palma o como no bosque o bosque. En este caso sí vimos que varios polígonos de palma sí se fueron detectados como bosque, pero tampoco usamos un polígono de entrenamiento de palma. Entonces eso fue algo que vimos que podíamos mejorar. Obviamente por el tiempo no lo hicimos, pero para el ejercicio estuvo interesante observar y comparar esta información que capturamos de un producto que se genera en Costa Rica a partir de observación de la tierra. Y modificaremos en los scripts incluir otras capas de entrenamiento, como la que comentábamos ahora, y también, bueno, si se quiere hacer más complicado, clasificaciones relacionadas con reportes de IPCC. Gracias por la atención, ahí estamos atentos a consultas. Jeffrey Smith.
You're muted.
Yeah, sorry. Let's go to number 2.
Thank you, Rafael.
Yeah, thanks very much.
CONAFOR.
Hola.
Hola.
Buenas, mi nombre es Marilyn y estoy en el grupo, en el Breakout Room 2, con Armando y con Ileana y Milagro. Armando, Milagro y yo trabajamos en PRIAS, que es un laboratorio del Centro Nacional de Tecnología de Costa Rica, y Milagro, y Ileana, que trabaja en el CONAFOR de México. Y bueno, seleccionamos a Costa Rica porque ya habíamos trabajado en México en la mañana. Utilizamos 7 áreas de entrenamiento para cada uno de los usos de suelo: bosque, no bosque, y bueno, de cobertura, perdón, bosque, no bosque y agua, con las imágenes lanza 2019. Y bueno, Armando nos va a comentar un poquito las cosas que funcionaron y las que no funcionaron tan bien.
Bueno, buenos días. Espero que se encuentren bien. Una de las cosas que pudimos encontrar que puede trabajar bien, bueno, en caso para Costa Rica, ¿verdad? Es lo de la cobertura de nubes. Bueno, como lo mencionaba Rafael, ¿verdad? Digamos, en Costa Rica hay la cantidad de nubes es sumamente grande, ¿verdad? Entonces, si utilizamos una cobertura mayor al 50%, creo que el mosaico va a quedar con muy poca información, ¿verdad? Entonces, creo que es una de las cosas que sí vimos, ¿verdad? También otra de las cosas, porque hicimos varios mapas, fue que entre mayor cantidad de áreas de entrenamiento se hagan, ¿verdad? Esto puede implicar también, ¿verdad?, en la depuración que pueden haber en la clasificación. Hicimos un mapa y bueno, nos salió, bueno, lo que nosotros llamamos salpimienta. No sé si es bien conocido, ¿verdad?, el término. Entonces vimos que a pesar de que hicimos mayor cantidad de áreas de entrenamiento, esto puede influir en que la clasificación no sea tan correcta, ¿verdad? Entonces, también, bueno, podemos jugar estuvimos viendo, ¿verdad?, que podemos jugar con los años, ¿verdad? Tal vez en unos años se puede ver mucho mejor. Y lo otro también, estamos utilizando una imagen de ¿verdad?, que es de 30 por 30, y en eso va a hacer que clasificación no sea como tan idónea, ¿verdad? Entonces fue una de las cosas que vimos ahí. Y ahorita, bueno, también la compañera Ileana nos va a comentar un poco de lo que también vimos.
Armando, si me permiten un momentito antes de que Ileana nos haga el comentario sobre estas imágenes que nosotros vemos acá. Eso es en el Pacífico de Costa Rica, la que está más al lado derecho, y ahí se ve, digamos, que hay bosque o cobertura arbórea, como quieran llamarle, y la clasificación no lo detectó, lo clasificó todo como no bosque. Entonces, una de las cosas importantes sería también agregar más puntos de entrenamiento para ese tipo de cobertura. Y lo contrario pasó allá en el Golfo de Nicoya, donde podemos ver que al meter tantas áreas de entrenamiento en agua, incluso hasta las camaroneras fueron detectadas. Entonces, fueron dos cosillas que encontramos ahí interesantes. Dale, Eliana.
Sí, gracias, Marilyn. Pues nosotros ya, por último, vimos la parte de qué haríamos después, y nosotros proponemos comparar este resultado, bueno, ya un mapa más preciso con quizá más puntos de entrenamiento y más clases, compararlo con los mapas nacionales existentes, tanto de este ejemplo que tuvimos de Costa Rica como para México. Y en ese tenor, saber si uno de estos mapas pudiera servir como mapa de validación para otro tipo de cuestiones que se están haciendo tanto en Costa Rica como en México, de validación en cuanto a la segmentación. A los segmentadores, los polígonos que se generan, si pudiésemos utilizar uno de estos mapas de clasificación como tal para validarlos. Y de la mano con esto, también saber si se pudiera hacer una capacitación para Google Earth Engine, pero en lugar de utilizar una cartera de datos Landsat, si se pudiera con Sentinel, justamente para ver si sería posible obtener mayor detalle o mayor precisión en cuanto a la clasificación. Y pues eso sería todo por nuestra parte.
Okay, thanks very much, Ileana. Yeah, it is possible to swap in Sentinel data, as you suggested. And of course, it brings up a whole bunch of other complications that we then work our way through. So that is something that technically you can do pretty easily by bringing in a different image collection and simply hitting run again to see what happens. Then the work begins of trying to do it carefully. Okay, so Rylan, let's go to the next group afterwards. I think that is slide 8.
Hello, this is Angela, and this group is formed by Juan Rubiano, Ezequiel Ruiz, and Juan Espinosa. We selected Colombia as our study site, and we run 2 different models. So in the top picture, we selected years 2018 and 2019, and in the lower picture, we only took 2019. As the previous team, we found lots of clouds as the main problem for this country, and doing a right classification. And we also select the 3 classes: forest, no forest, and water. And in both models that we run, we selected different, like the training, we select different sites. In the top picture, we took some more sites, like 9 samples for forest, 16 for no forest, and 12 for water, whereas in the lower picture, it was 5 forest, 7 no forest, and 8 water. And on top of that, on the top picture, we focus more selecting those sites in the north region, whereas the second model, we focus on the Amazonia region in the south. So we got 2 very different maps. And from these, we come with the big problem that we have with the clouds, and so the lack of images, and also the importance of getting more sites for the training and getting right maps. And yeah, I don't know if any of my colleagues want to add something.
Sí, buenos días. Soy yo, Juan Carlos Rubiano. Yo trabajo en Colombia, en el IDEAM. Digamos que nosotros en nuestros resultados que hicimos de nuestro grupo, lo que también detectamos es que en el mapa de la parte superior, pues lo que hicimos fue que se generaron más muestras de áreas de no bosque, y como la zona es mucho más diversa que el área inferior, que es la de la Amazonía, entonces por eso salieron los resultados con más áreas de no bosque, que en realidad sí son así. Y en la parte de abajo, en el mapa inferior se generaron zonas de... O sea, las muestras que sacaron, como son de la Amazonía, y la Amazonía es más homogénea, entonces las muestras salieron más, en el mapa inferior salieron más, el bosque salió más definido. Pero es de acuerdo a la cantidad de muestras que tomaron y todo esto, por eso es que nosotros, digamos, quisiéramos después hacer un ejercicio más completo. También otra cuestión que sí nos gustaría saber es si puede haber un entrenamiento donde de Google Earth Engine, donde podamos tener mapas de cambio de 2 periodos distintos, a ver cómo pueden, digamos, un cambio en el bosque, así sea para deforestación o ya pues si se puede incluir otras coberturas también, pero digamos que es como lo que más sacamos de resultados en este grupo. No sé si algún otro, si Juan Espinosa quisiera hablar algo más.
Okay, I think that's great. Let me suggest we go to the next one, but I do want to ask you that the point of what you want to do next is important for me as well. Soon we'll ask you about doing a survey for at the end of the time. So if you want to hear about changes through time, then please put that on the survey when we say, what would you like to know about next? So you can imagine how complicated it is when we have maybe low quality images for 2019 and high quality images for 2020. It maybe would give the appearance of a complete change of land cover in one picture to another, from one year to another. So that carefulness is really a big, it's a very difficult problem. Okay, let's go to the next breakout room. Thanks again, Juan Carlos and everybody. Let's go to Edward and Sebastian.
Gracias a ustedes.
Hello. Good afternoon, everybody. Sebastian, I don't know if Edward is also available. Anyway, I can start off. We were just the two of us in the room, and well, we had to adapt the script as everybody else from Mexico to their country. In our case, Zambia. We're both working for the forestry department in Zambia, so for the government, and we're actually currently working on we want to produce a good land cover map of the country. So for that reason, this training was really timely, and we hope to continue working like this. So well, we did probably the work that most people did. We deleted the Mexico vector file, so we took some samples from forest, non-forest, and water in Zambia, and we created one map. Then we took a few more samples, and we created another map. And you can see in the bottom, yeah, the difference that came out. The difference are quite minimal, to be honest. If you see it a little bit bigger, you can see that here in some areas there's a bit more non-forest where the amount of samples was bigger. I think the real challenge will come in if we add more classes, like we create cropland, we create a few other land cover classes. I think for each additional class you will create more complexity and also more error for that reason. And then, yeah, Zambia is quite complex with a lot of seasonality, which gives a certain level of complexity. And then forest and non-forest is not always that easy to separate, because the forest is quite not very dense, and then there's grassland with also trees. So those type of separations will be challenging, but nevertheless very interesting to work on. So this is just, but I think this has been a real good exercise to learn working with the scripts and see how we can take it from there. So it looks a bit drafty. We got this template at a bit at the last moment, so we didn't really had a lot of time to work on it. I don't know, Edward, are you there? Can you say something about what we did?
I think you've pretty much.
Good.
Yeah. Yes, Sebastian, I'm here. I think you've pretty much exhausted everything that we did. Yeah, though we didn't exactly attempt the cropland aspect, but that is something that we thought we could also introduce. Yeah, obviously for future practice and whatnot, I think that we'll try to do that. And like you rightly indicated, we are working towards developing the land cover map. So I'm sure this training has really come timely and it will surely help us in that regard. Thank you.
Great, thanks, Edward. Then, yeah, I guess we can leave it at that. We indeed were in the process of trying to create cropland as an additional class, and then see what changes in the script we would need to make it run. We didn't get yet to that level to try it out, but I'm sure that that's doable, and it would be interesting to see how that will come out. All right, eso es todo.
Okay, great. Thanks very much, Sebastian. All right, let's go to the next one. We'll hear from Paul and Rich and Rupesh.
Yeah, I think Paul.
Sorry,
we did. Do you?
Yeah, we didn't just. I don't care. Any of us. Okay. We tried to classify mangrove forest, forest, non-forest, and water. So we added an extra class. The process worked well with 4 classes. What didn't work was mangrove and forest were too similar spectrally. So we couldn't split them apart reliably. You can see in the top, we have mangrove forest up in the mountains, which is clearly a problem. So we didn't know our classes, like it didn't train as well as we would have liked. So we don't know if it was because they were poorly chosen sites or we didn't have enough sites. Some of the questions we had were how many samples we would like to use per class. We didn't know if we needed 20, 100, 30, whatever. We didn't know if there was a threshold that we needed to meet in each site. We tried to pick diverse sites, but obviously we didn't have a lot of time. We struggled with, the question we had is, how do you define your classes? Some of the things we wanted to do were to create a legend. We also wanted to use other imagery, like say the height of the data, the height of the surface, like mangroves are not very tall, but the upland forest is quite tall. So we would have liked to have been able to sort out the classes based on height. So that, like in terms of other training data we wanted to get, we would have liked to have been able to add a DEM and a surface height map. Were there other things, Rich and Rupesh?
I think that was it.
Yeah, thank you, Paul and Rich. That's all.
Okay, thanks, guys. Let's go to the next room 7.
Hola, buenos días. ¿Sí me escuchan? Ok, una disculpa porque no tengo mi cámara encendida, no sirve, pero les voy a explicar un poco el ejercicio que hicimos Juan Pablo, Marco y un servidor. El ejercicio de clasificación iniciamos por hacer un ejercicio subnacional en México. El ejercicio que realizamos al principio pues fue para todo el país. En este caso utilizamos un solo estado. De los 32 que tiene México, utilizamos un estado que es donde está la Comisión Nacional Forestal para realizar la clasificación. Entonces importamos el archivo shapefile del estado y nos basamos en ese para hacer la clasificación. Ahí utilizamos, incluimos 4 clases, que fue la cobertura forestal, urbano, agrícola y agua. 6 muestras para cada una de las clases. Las clases se insertaron de forma visual, sabiendo mediante fotointerpretación dónde se ubica cada una de las clases. Utilizamos el año 2019 para realizar esta clasificación. Tuvimos un poco, creemos que la clasificación fue buena. En realidad es muy eficiente el proceso, es práctico. Sin embargo, creemos que los resultados se pueden mejorar, pero los resultados se pueden mejorar pues obviamente a través de datos de campo, a datos de entrenamiento más precisos. Por ejemplo, en la parte izquierda de la pantalla nosotros mostramos que al centro occidente de Jalisco hay una importante clase en color naranja, es que creemos que puede depurarse. ¿Por qué? Porque ahí se encuentran creemos que hay un poco de confusión en cuanto a vegetación de matorrales, vegetación arbustiva con algunas otras clases que pueden ser agrícolas o pastizales, pero sin embargo nosotros tenemos claro que usando mejores métodos de entrenamiento, mejores insumos, podemos nosotros mejorar esa clasificación. Obviamente lo mismo pasa con las zonas arbóreas, las zonas de vegetación. También tenemos muy numerosos tipos de vegetación que también, si nosotros comenzamos a integrar más datos, posiblemente mejoremos esta clasificación. Inclusive también las zonas áridas y zonas semiáridas, que generalmente pues se confunden con suelos desnudos o con pastizales. Eso es como nosotros tenemos también bases de datos, tanto shapefiles como puntos de datos de campo con el que nosotros podemos utilizar como zonas de entrenamiento para poder mejorar nuestra clasificación. En México actualmente estamos generando algunos mapas de cambios de cobertura y de cobertura, que creemos que estas herramientas pues obviamente nos van a ser muy útiles también aprenderlas y manejarlas para poder optimizar nuestros procesos. Principalmente también pues por el rendimiento que tiene el proceso. El realizar estos procesos en una máquina convencional pues no es tan bueno como lo es esta plataforma, ¿no? Y algo importante y que sí pusimos en el cuestionario de la encuesta, pues es de que este procesamiento también nos interesaría conocer o saber el procesar imágenes, por ejemplo, de satélites activos como radar o LiDAR o Sentinel-1 para poder realizar algunos otros procesos dentro de la plataforma. Bueno, no sé si mencioné al inicio, nosotros somos parte de la Comisión Nacional Forestal los 3 y nos tocó hacer equipo para esta clasificación. Si mis compañeros tienen algo que adicionar, pues se los agradezco. Y gracias a todos. Un saludo.
No, creo que César comentó todo lo que hicimos, solo también habíamos platicado de que podríamos mejorar mucho este mapa. A lo mejor en vez de tener como en esta 6 puntos, podríamos tener a lo mejor miles de puntos de entrenamiento y que mejorara mucho esta clasificación, ¿no? Y agregar mucho más clases, ¿no? Tal vez, aunque bueno, está la disyuntiva que se hace más complejo, ¿no?
Okay, that's great. Thanks, Marco. Yeah, there really is a tension that I hear in all of these presentations about just having a few points and then you get a kind of simple result. And the need probably to have lots and lots more information that you can feed into the random forest or whatever is the other machine learning technique that we use. I know this is a thing that Rylan is spending a lot of time on as he starts his master's, is thinking about the balance of training points, the number of training points, the number of classes, when to split apart classes. Do you do that at the training period and then reunite them at the end? So all of the pieces of these problems that you're imagining are the problems that we also hit, that you also will hit if you continue doing this in a lot of detail. You'll probably still be talking about those same problems a year from now, if you're trying to make even something that is fantastic and perfect and not just as an introductory project like this. All right, let's go to the very last one. And we'll move now to Peru.
Hola, ¿qué tal? Buenos días. Yo soy Miriam Vargas, soy de México, solamente que el país de interés fue Perú, porque ya habíamos hecho México. Yo trabajé con Bupem Sonda de Zambia, y entonces decidimos trabajar Perú como país de interés, esto para variar un poquito, utilizando el mosaico como referencia de 2018, e hicimos una clasificación sencilla de bosque, no bosque y agua, ¿no? Los parámetros que le cambiamos, bueno, fueron pocos. Ahí creo que nos falló un poquito lo de las nubes, porque hubo muchas máscaras de nubes, entonces a lo mejor utilizar unas imágenes con menos nubes hubiera sido mejor. Pero bueno, aún así pudimos hacer esta clasificación. Como les comento, es muy sencilla. Aquí no conozco mucho sobre la vegetación de Perú, sin embargo sé que tiene una parte con mucha vegetación, toda el Amazonas en la parte norte, y también tiene mucha zona de desierto cerca de la costa, ¿no? No nos fuimos a más detalle por tipos de vegetación, una porque no conocemos tanto, y la otra porque, bueno, pues implicaría muchísimo más tiempo sacar tantas muestras. Sobre el script, bueno, utilizamos el que tenía el ejemplo y solo hicimos estos pequeños cambios. Ahí tuvimos un problema para definir el nombre, no sabíamos si había un código por país para cambiarlo, pero bueno, al final nada más fue cambiar el nombre del país y con eso fue suficiente, ¿no? En cuanto a las muestras, obtuvimos 15 para bosque, 16 para no bosque y 19 para agua. Aquí, bueno, pues no sabíamos cuántas se tendrían que hacer para cada uno. Sabemos que entre más muestras, pues el resultado va a ser mejor. Sin embargo, pues tampoco tuvimos tanto tiempo para esto, ¿no? Entonces, tomar las muestras como diferentes lugares creo que sirvió un poquito para que, en términos generales, pues se viera bien el mapa. Ya a detalle, no sé qué tan real sea. Y bueno, pues estas muestras se tomaron de forma visual sobre el mosaico que se había generado de 2018. Y anteriormente cambiamos al año 2000, pero no apareció nada en el mosaico. No sé si hubo algo mal en el script o fue un problema de que no había imágenes, aunque no creo que haya sido eso. Pero bueno, sería cuestión de verlo para otros años y bueno, quedó 2018, ¿no? ¿Qué nos gustaría hacer después? Bueno, yo creo que intentar clasificar un área más pequeña podría mejorar la clasificación, porque sería un área que podríamos conocer más e incluso buscar información en otras fuentes de datos que nos ayuden a decidir qué es lo que estamos viendo y sobre todo para utilizar más clases, ¿no? Entonces, bueno, esa podría ser una opción. Nos gustaría intentar como lo hizo con Afora a nivel subnacional, en zonas más pequeñas donde se tenga mejor control sobre lo que se ve y sobre los tipos de vegetación que se conocen. Bueno, ahí mismo también pues nos gustaría crear más clases para diferentes tipos de vegetación, no nada más bosque, no bosque y agua, sino para ver que también trabaja la plataforma con más tipos de vegetación. Como comentaba César, hace rato nosotros estamos trabajando con una clasificación de 32 clases, me parece. Y bueno, pues ahí
34.
hay 34, perdón. Bueno, es que están las de pastizales. Entonces, bueno, eso a lo mejor en un país como este, pues también es mucho, pero creo que valdría la pena intentarlo para ver cuáles son los resultados. También pensamos que sería bueno crear series de tiempo, sobre todo para conocer como los diferentes estados de la vegetación. Comentaba Bupe que, bueno, para saber como efectos de degradación o a lo mejor de recuperación en la vegetación, porque conociendo nada más sobre un tiempo, pues nada más podemos ver la fotografía de ese momento. Y bueno, cosas que nos gustarían sobre próximos talleres o entrenamientos, bueno, pues aprender un poquito más sobre códigos o lenguajes como Java o Python y bueno, poder crear mapas de cambio de cobertura. A la par de este ejercicio, Bupe estuvo trabajando en su país, en Zambia. Sin embargo, bueno, ahí estuvimos resolviendo algunas cosas y surgieron algunos problemas. Entonces, no sé si Bupe quisiera comentar algo sobre los problemas específicos que ella tuvo.
Maria.
Sí.
Yes, I think you've mentioned most of the things, but what I wanted to find out was if we could, if it's possible to subcategorize like for the forest, like here in Zambia, we have different types of vegetations. Sometimes you can find that an area can be classified as it's a wetland, but then it falls under the moist evergreen forest. So I don't know if it's possible to reclassify those areas so that it can even show, like if you produce a map, it shows that this is a wetland and not just being classified on moist evergreen. I think that would help a lot.
Okay, that's neat. Are you asking about doing sort of two different classifications and then combining them, like two different processes and then combining them?
Yes.
Yeah, so, well, that's where there are a lot of options for what to do next, right? You can give a lot more points. That's something that we've heard a lot about. There's also the possibility of saying, okay, well, I'm just going to do water versus land first. Then I'm going to take all of those pixels and move them out of this classification problem and put them in a little box. Now I'm going to do forest versus non-forest. I'm going to take all of the forest pixels and now put all of them in a box. And so sometimes you get the same answer and sometimes you get a different answer. But you know, with the application of time and a lot of creativity, typically you can get the solution that you want. Sometimes by combining multiple images together, sometimes by creating a time series, and sometimes by using a different classification technique. So there are so many different ways of doing this. And I believe at least there's no single perfect right way to get a good answer. If so, we would teach that right away and not explain any of the complexities. So it's a complex process, but in general, you can get to the answer that you want. So before we leave this slide, I'm wondering, Rylan, if I can ask you to improvise talking for a minute about the risk of overfitting, or what it looks like when you overfit. Here, I would call, we have just a few points for every class. And so maybe we expect that we're missing something in the types of, the variety of land cover is pretty variable, but we only have 10 points for one thing and 15 points for another. So I'm wondering, Rylan, can you talk about at the other end of the spectrum, when you give so much data that the model has a specific item for each little data point? Can you explain that? I imagine it's hard to do, but if you could explain that a little bit, that would be helpful.
Yeah, possibly. At a certain point, if you have too much training data, which is a lot more training data than anyone has shown in their examples, the model stops generalizing from those training points and essentially just memorizes them. So rather than classifying similar pixels as being forest, all it sees is that I've seen this exact pixel before, and so I'm going to classify it as forest. And this can be a problem if your training data was not 100% representative of everything that it could have possibly seen. So if you drew all your points from a smaller region and then try to generalize to a much larger region, if you've overfit, the model's just applying what it's memorized, but if it memorized the wrong points, the generalization could be really bad. Is that kind of what you wanted me to talk about, Jeff?
Yeah, I think so. And it's if I understand you right from your computer science classes, it's a big enough topic that they spend a considerable amount of time talking about that in a computer science course, right? Not just underfitting and then everything's perfect, or you use just a few points and there's an easy rule of thumb, but it seems like there's trial and error involved also, even with really sophisticated models as well.
Yeah, I think with pretty much any classification task, there's always some element of trial and error. And even if you come up with the right parameters, steps, number of samples per class, and you create a really good map for one region, that right set of parameters is not necessarily the right set of parameters for a different region. And so every time you do it, there is an element of trial and error to create a good classification.
Okay, great. Yeah, and so to everyone, I'll say, thinking back to the slides. Oh, Rylan, why don't we go back to the home slide, slide 3, back in part 1. And if you remember, we talked about trial and error at the very, very beginning, like half an hour into yesterday, when we said Earth Engine is really useful for trial and error. It allows us to make mistakes, to learn from them, and to then create a new model. We can do something badly. It doesn't take 3 months to do that action, like it might if we were doing it on our own computers. And so we can play around a lot in order to try to iterate toward the right answer, rather than a different way of solving a problem is to try to predict everything that can go wrong and to try to cover all of the problems before you start. And only go through the steps once. For certain kinds of problems, that's our only choice. With Earth Engine, we can often do a lot of iteration toward getting a better solution. So now we're going to turn to the end part of what we want to do together. You can see down on our day 2 on our calendar, we have from 11:30 to 11:45. We want to all do a photo, a group photo, where if we were in real life, we would all go stand outside near each other, and we would take a photograph. So what we want to do now is ask you all to turn on your cameras. And when we do that, then Monica will take a picture of all of us. So, Rylan, I guess you unshare your screen. We want to ask everyone to turn on your cameras. And Monica, I guess you take it from there.
Yes, and because we are 35 in screens right now, what I will do is just let you know when I'm taking the first screen and who's on the first screen, and I'm gonna tell you when, so you put your best face. Okay, I'm in screen 1, and it's just 2 screens, and I'm missing Cesar Garcia picture, but if you don't want a picture, if you don't want to share your camera, it's fine.
Perdón, ya me conecté de otro dispositivo porque mi cámara no enciende en la computadora. Entonces estoy conectado 2 veces.
Okay.
No problem.
I'll Photoshop your picture later. No, that's a joke.
Yeah.
Okay. I tell you when. 1, 2, 3. Done, first screen. Go to the second screen, start with Juan Pablo, and we end up with Dereje. I have Omar Sotelo, Carol Beneses, Milagros Jimenez, and Janet Alvear. No showing camera, but that's okay. Okay.
Es que yo también estoy con dos dispositivos, desde mi celular y desde el computador. En el computador no tengo cámara, entonces estoy desde el celular. Pero ya cierro esa sesión.
Pero te veo, Sotelo. Yes. Okay, I go. 1, 2, 3. Perfect. Thank you very much.
Okay, great. So, Monica, I don't know if you're sharing your screen. If you can stop sharing it, and then Rylan, come back up if you would. And let's go to slide 3 again to the home screen, the home page. Okay, so from now to 11:45, we are going to tell you about some additional resources. Let me just recap what we've done just one more time. So we began on the first day, that's yesterday now, with what we do in my lab. And so some of the things that we do in my lab, we've touched on today and also yesterday. So I specialize in time series. And so when we are looking at creating a series of land cover maps that are consistent with each other, that don't show land turning, for example, from forest to mangrove to forest to mangrove to water over a 5-year period, or from forest to burned area to forest to burned area over a 2-year, 4-year period. That's the kind of thing that we focus on a lot within my group. So you heard the different angles for how we do that, just from Rylan with machine learning, from Africa with SAR, and then also the others in my group. If you mentioned the name Morgan, who I mentioned, does that for fire. And we use this algorithm called bulk. That's the thing that I do, which we maybe someday talk about. So when we go to what is Google Earth Engine, you heard about that. We then marched through part 5, doing Earth Engine 101 with the document, both in Spanish and in English. And we talked about got you started all the way from not knowing where the run button was, all the way to now being able to create a classification of a whole country in a few minutes. So then, and that's what we did beginning today there with part 6. We did that whole group exercise that Africa walked us through. And then we just, as everybody knows, went through the small groups. So what I want to do now, I'll mention that the posters that you made, they're sort of toy posters, but we will leave them up forever. I never delete any files ever. And so those posters will be there when I retire. They will be still sitting in this little folder here. So let's now go to the additional resources. If you can go down, Rylan, that is down at slide 15. Okay, so actually, Rylan, if you could unshare your screen or unpresent and then represent. I moved a few things around on this page. So maybe it will update then. But what's shown there on slide 15 is the beginnings of these additional resources. Rylan, you should see 2 boxes on that slide 15 once it updates, I think.
Sorry, I have like 100 tabs open, so it's taking me a moment to find it, but we'll be there in a second.
Yeah, no problem. So when you see this in a few seconds, what we'll show you are some general resources and even a few specific resources. So what you see there on the left is some high-scale links toward materials to begin to learn more. Someone earlier had asked today about a user's manual. Here, if you click on that link on your own, you'll see it's a Google Earth Engine user's guide. There also have been some efforts for creating resources for higher education. In my own lab over the next year, we're hoping to write a book that will do this same kind of stuff for the fundamentals and applications of Earth Engine. That's not on the list yet. And then third is the Geo for Good. So Google each year has a 2 or 3 day workshop where they bring people in from all over the world who use not only Earth Engine, but other mapping technologies that they have at Google, such as Google Earth, and which many of us know quite well there too, but also gathering information in a toolkit that they have where you can gather information on your phone. It goes automatically to Google servers, that sort of stuff. So you can learn about their huge range of information for using geographic information for good. You also, as part of it, can watch all of the presentations that are presented there by clicking on that link. There also are YouTube channels that exist. This, the 4th item is a link to the main one for, in particular, for using Earth Engine and Python. And so he updates this YouTube channel very often. I just saw on Twitter today, he said, hey, I've made a new update that allows you to bring in different types of data into Earth Engine than had been there before. There also are question and answer platforms. So Stack Exchange, which many of you probably know, has a whole area for Earth Engine. I just used it on Friday in order to begin to answer a question that I was stuck on. There also are abilities to use Earth Engine at the command line, not only with the graphical programming interface that we have here, or the interpretation interface that we have here. You also can run through the command line as well. There are postings that have been put up by Google people as they develop them, and some of you might remember we went a little bit through this list the other day. It may not have meant so much when you first saw it yesterday, but hopefully it'll give a little more context to hear it now this time. There are those Medium postings, the Ladies of Landsat link. They just posted today. They do it each Monday, so I guess it was yesterday. They do a weekly highlight of a paper. There are these short presentations at the AGU booth, and you can learn more about our lab and, of course, contact any of us by clicking on that link down there at the bottom. Over on the right, that was what I just added in while we were talking today. So the Mangrove Mapping, there are little sessions that exist for almost all of the topics that we've talked about today. This Mangrove Mapping is a symposium that was done through Servir Amazonia over a 3 or 4 day period. And if you go and click there, you'll be able to see a link for the agenda for all of those days. And so for the people who are interested in particular in mangroves, you can almost definitely learn a lot by going and checking out that work. If you want to learn more about random forests, so that is this particular type of machine learning where you get classification and regression trees. So what we did today was we worked with classification and regression trees, but what happens there is maybe you miss something when you split data into training and testing. What random forests refers to is taking all of your data, imagine that you had 2,000 points, and splitting it at random into a group of 1,000 points for training and 1,000 points for testing. You get a tree. The tree says if the pixel is this color, we're going to call it that. But then maybe we'll resplit it again to make a new random set of training and testing points from that big list of 2,000 and make another tree, and then make another tree and another tree. After you make 10,000 trees, then you say, how often was this pixel classified as forest and how often was it classified as a city? Well, if it's classified as a forest 90% of the time, I feel pretty confident that it's a forest. Maybe if I only ran it once, that pixel would have been called a city, but by running it 10,000 times, I can get a better sense. According to the I don't know, bootstrapped information, I can get a better sense of what it is likely to be. So that's what you see there in item number 2. For item number 3, rapid classification of croplands, you could learn more about that. And then a ton more about supervised classification and regression with that link. There also is a lot of work, you can probably imagine, there's a lot of work in sampling within remote sensing, and a lot of progress has been made in the last few years about how to estimate area and map accuracy. In the same kind of way, as I was saying with the random forest, if you pick 100 points to evaluate your classification, maybe you get unlucky and it might tell you that your classification is really bad. So there are more statistically sound ways of doing it than just running the sample once, or we can compensate for the different numbers of classes and different numbers of points in different classes. And then the RTC data, I have to confess, I don't remember what that is. So maybe Africa could say what that one is. I think you pasted that one in. Is that right, Africa?
Yeah, it's just about the Sentinel-1 question, or to include the Sentinel-1 in the analysis. So I think that I had mentioned before that we need the right Sentinel-1 product to include for the land cover mapping, and that's the radiometric terrain correction product. And you can get that from Alaska Satellite Facility Vertex platform, and that's the link to the Vertex platform. And then you can go there and request RTC product and then upload it to GE. The Sentinel-1 product that is available in GE is GRD, is not terrain corrected.
Okay, that's great. Let's see, Rylan, let me ask you to go back to slide 13. Okay, and this is a little review of what we did. So if you remember yesterday, not everyone didn't know how to use it, but many of us were kind of unfamiliar with the screen and what it is, even that could be done within Earth Engine, what it meant to use Earth Engine. But to do that, we needed to learn about JavaScript. We needed to learn some of the basics. So if you go back and look at that Earth Engine 101, we print something to the screen. We print hello world to the screen. We make a function that allows us to print hello anything to the screen. We make a variable, we make a list, we make a dictionary. All of those things are very simple, but they all came up today, really, in the first 10 minutes of what Africa showed. And so they really are the building blocks. They might seem simple, but computer programs are built from simple foundations in order to build a program with complex behavior. We did logical operators that was greater than 2000, working with the elevation. We did map.add layer and looked at the different parameters that we could use for that. We did reduce regions, and we talked about that today also, I think, in the beginning. Filtering the date, that also came up today as well. Mapping a function over a collection, I believe we did that with the clouds. And doing a mosaic, we did that as well. We also have the ability to do exporting and charting. We didn't cover that, but maybe if we all meet up again, we'll be able to show you that. Where can you learn that on your own if you want to? Let's go just for a second. I'll tell you that in a minute. Let's go to slide 10, the next slide that says classification. So what did we do today? We did, we took a multi-date classification. We made a cloud-free composite, visualized it. We did some, the rudimentary approximation of what it means to get training data. We learned the mechanism for, the simplest mechanism for making training data. We then actually executed one of the many, many classification tools that exists in Earth Engine. You could watch a 1-hour talk about different classification techniques just within Earth Engine if you go to that Geo for Good. Or if you look on YouTube, there are at least 5 videos that show the different classifications and the different classification techniques. We saw one, which was CART. We then generated the land cover map. And then, of course, it's a whole additional enormous process to evaluate whether your map is good or not. Maybe, as we were saying before, maybe it's perfect. It's very seldom perfect the first time, but how imperfect is it? And at what level of perfection or imperfection does a map become useful? And those are deep questions as well as technical questions. We're not going to cover all of those today, but those are things that come up all the time for us. So there is a question here about segmentation and object-based classification. You can do segmentation in Earth Engine. There's a whole 1-hour talk on that as well that was given at 2 years ago. Also, my own lab, we did a workshop on segmentation at this Geo for Good conference in 2018. That has been recorded, and anybody who wants to learn about that, we could link you to that. Also, we, as part of that, we have scripts that you can just push the button and learn how segmentation works. So I think they're pretty valuable. They use modules, which was something that we saw just real quickly today. When you, where Africa was clicking on assets, next to that was the ability to have your programs kind of collected into a module. So if you want to learn more about segmentation, I love that stuff. That would be really fun to talk about sometime. All right, so I love that. I really love that stuff. So let's go to slide, where to? 16, 17, almost. Yeah, let's go to slide 17. So if you wanted to learn backwards one, if you would, Rylan, if you go to this says Earth Engine 102. Well, what is 102? 102 is just one of many, many more levels, or at least 5 more levels, let's say, that you can learn by following through a repository and following through a script like we have here. Africa mentioned Nick Clinton. He's one of the Google outreach coordinators. He's a programmer who joined with Google 5 or so years ago and has created this slightly more advanced, actually quite a bit more advanced repository with a script going along with that too. What that allows us to do is to do dates that use multiple dates and creating a stack, creating a multi-band image from an image collection. In fact, I have a script on my screen over there that I believe copied from that part right there, converting an image collection, and I used it yesterday. So this idea of taking little snippets that you saw us do, that really is what we do. So we have a problem, we try to find it, maybe at Stack Exchange, maybe by asking someone who we think knows how to do it. They send us some code, we try to put it in, we change around the variables, we change around the parameters. And hopefully it works. So hopefully now that vocabulary of talking about functions and parameters and code snippets. Hopefully that is more familiar to you than it was before, and that we've given you at least enough to begin to continue your journey in with Earth Engine. All right, let's go to the next slide. And with that part, we want to ask you to fill out this survey. And I really want to know, I think all of us involved in this really want to know what works, but also what doesn't work. If we, for example, if we didn't spend enough time talking through your posters, we just made that up, to be honest, last week, thinking maybe having posters would be a way to sort of get everyone into the same room with the same thinking. And all hearing the same thing again at the end of the process. But we didn't really allocate enough time to ask questions or to comment on them. Maybe you feel we should give more time. We would love to know that sort of thing. And that's what we asked for in the end of workshop survey. So if we could go to slide 19. That is our next to last slide for this whole thing. So returning to our learning objectives. Gaining confidence using the Earth Engine JavaScript API. I'm not going to click there. Let's look here. We will go to then learning. What you did was you learned how to create scripts. You learned how to customize scripts. You learned how to get other information from other places and paste it in and then work with it. Hopefully you are connected with others. You feel connected, at least somewhat, with the others who are in this group, and that will be something that you can hold on to. We just went over some of the additional resources. There really are quite a few. And we hope that you are feeling inspired to make your own scripts and to fail bravely at making scripts and to be a little bit happy when things don't work, because it didn't take a month to have them break. It only took a few seconds for them to break. So let's go to the very last slide, which is our thank you slide for today, where we want to thank Sylvia for setting this up and Monica for her work constantly through this whole entire process, and Maria as well for her really very strong interpretation. I myself just realized that I could push English in order to hear you translating then back from Spanish into English. So thanks for doing that too. I understood exactly what you were talking about the whole time. So this is our Google 101 Earth Engine training. I am one of your 3 hosts. You can see that Africa and Rylan as well also know very much what they're talking about and would be great assets for you to contact, as well as myself. We look forward to hearing from any of you at any time. And especially we'd like to know what you want to know next. So my hope is that you will continue to use Earth Engine for a long time to come, and that we'll all see each other in person sometime soon. All right, thanks very much. And we'll stay here for a few minutes for anybody who has any specific questions, but if you want to go, if you need to go, you can feel free to be released now. Thanks.
Bueno, yo solamente quería dar gracias a todos los participantes y obviamente a McGill, a gracias de SilvaCarbon. Agradecemos muchísimo su participación y dentro de unos días, si es que no es hoy, estaremos compartiendo de las grabaciones de ayer y de hoy. Por favor, muchas gracias y que tengan un bonito fin de semana.
Muchas gracias.
Gracias. Saludos a todos.
Bye. Thank you so much.
Thanks, everyone. That was a great course. I really appreciate it, Jeff and Ryland and Africa. I really learned a lot, so thank you. And look forward to talking to you guys more about maybe doing some mangrove change detection.
Same here. That sounds fun. And check out that workshop too that I mentioned there. I think it looked pretty good. Great.
Definitely. All right.
Stay
warm up there.
Take care.
Yeah, everyone.
A mí me gustaría quedarme para atender una duda. No sé si alguien de México también gustaría quedarse.
Okay, sure.
Sí, yo también me quedo.
En especial Marco también, César. Ok, se va a quedar Ileana. Muy bien. ¿Y Norma?
También se queda.
Ok, gracias, Norma. My English is not very good, so I'm going to talk
Okay, sure. Why don't we start with that question?
Yeah. Okay. Con todos estos ejercicios me di cuenta del poder de procesamiento y se me ocurrió hacer un ejercicio para México, pero no sé si sea bueno o prudente, debido a que estamos limitados de recursos humanos y de recursos también de cómputo, por así decirlo. Pero nosotros tenemos unas muestras que es el Inventario Nacional Forestal y de Suelos, que son 26,620 puntos a nivel nacional. Nosotros, esto se está haciendo una muestra en campo y cada cierto periodo, cada 4 o 5 años me parece. Entonces nosotros tenemos esta información disponible. No sé qué tan prudente o bueno sea utilizar este volumen de muestras, ya que recuerdo que Ryland mencionó que llega un punto en el que los algoritmos o la plataforma empieza a obviar la información que se está obteniendo de cada píxel. En este caso, pues como son puntos, sería de un píxel. Entonces, sí me gustaría lanzar también aquí la idea con el equipo. En especial, bueno, el que sabe programar más de nosotros es Marco Iñiguez. Ya nuestro equipo es vasto en unas disciplinas, pero él es el especialista. No sé si se pudiera hacer después como otra reunión un poco más técnica o para que nos retroalimenten para saber si se puede hacer algo con estas muestras que tenemos para transportarlas a una paleta de 34 categorías que estamos manejando para hacer para la proyección de un mapa nacional 2020. Pero por lo pronto estamos trabajando con uno 2016 y ya se han publicado 5 estados de cobertura, no de uso, sino de cobertura. Entonces, no sé si se pueda también combinar con estos mapas y esta fuente de información. Y más que todo, también saber qué número de muestras es recomendable que nos ayuden a posicionar en estas 34 clases, ya que veo que Ryland ha hecho varias pruebas en Machine Learning y Deep Learning para saber, como dice, no hacer el overfitting. Entonces, sí me gustaría saber si es probable hacer esta prueba. Y no sé si algún compañero también tenga algo que decir. Se me hace muy interesante.
I just would like to clarify the point I made earlier about overfitting and say that it is less to do with the total number of points that you have than it is the quality of points that you have. So even if you have many, many, many training points, if they are representative and diverse as your data and they represent it all, like having a lot of them is not going to necessarily lead to overfitting. The problem with overfitting comes from having too many points that are all similar, where the data that you're trying to generalize to has much more variety in it. So increasing the number of training points that you have is a good thing as long as the training points that you have are representative of the data that you're trying to learn from. And so it is not necessarily bad to increase or have too many training points. So I think I probably misspoke when I talked about this earlier. So more points, not necessarily bad, and does not necessarily lead to overfitting.
Yeah, well, I think it's not
Gracias.
exactly misspeaking, but it's like a really complicated thing to get right, I guess I would say. I wanted to bring it up so that people could hear about it. I worried a little bit too that it would make everybody say, well, I don't want to have too many points then. So, but it's a subtle factor. So maybe if I could remember when Africa was selecting points, there were some, I'm just going to call them by color. There were some that were a really darker green and some that were a light green. And there were some that were a light pink and some that were a dark pink. So if she quickly selected points and they were all dark green, and of the pink points that they were all pink, the dark pink, is that the kind of thing that would, I mean, it would be a mess maybe because it would be guessing about what to do with all the other points that aren't really well represented. Is that similar to overfitting, or is that another type of problem?
Me
I
gustaría
guess.
agregar algo al tema al respecto, en base a la experiencia. Hemos estado, por ejemplo, en el caso de agricultura que está protegida, los invernaderos tienen una reflectancia muy alta, son blancos, y realmente el uso de ese objeto es agricultura. Si nosotros colocamos áreas de entrenamiento en esta agricultura protegida, es muy probable que muchas áreas de ciudades queden clasificadas como agricultura. Hay un compromiso muy complejo y muy delicado en seleccionar las áreas de entrenamiento. También pasa lo contrario, pues hemos tenido suelo desnudo y área urbana, tienen calidades de reflectancia de brillo muy alto. Y entonces hemos tenido área urbana, por ejemplo, en el volcán de Colima, que es un área desprovista de vegetación, y ella aparece clasificado como un área urbana. Sabemos que son errores y allí no sé si ese es el tema clave en la selección de las áreas de entrenamiento.
May I mention a little bit about the sampling design for this? I first think that if you have all those samples already collected, that sounds great. I would like to know more about how did you collect them? Are these just for this year? Which tool did you use? Did you base them on high resolution data? But in addition to that, maybe you already follow a sampling design in which you have a good representation of the different land cover types that you want to map. And usually there is a process for that. And there is one of the links that Jeff mentioned for the estimation, area estimation, and sampling area can give you some introduction to that. You can have, for example, you already have a land cover map for Mexico that is similar to those classes that you want to reclassify. You can use that as the stratification layer, and then base your sampling design on that. And as Rylan mentioned, and Jeff as well, you have good quality training data, like that's the key. Obviously for this exercise, we were just showing you how to use the tool to collect reference data, and not actually going through the exercise of making sure that we will have all that topic, because that's a completely different topic that it requires a whole training by itself. But you can follow that link that is in the slide that Jeff walked us through right now to take that training. And it's an e-learning training that SilvaCarbon have put together as well. And the other thing, obviously you have more classes, there is more room for error, as Sebastian mentioned as well, but it's a process of trial and error. Something that is super nice with GE is that you can repeat this as many times as you want and customize and have as many iterations to improve your classification. And you can use a portion of your samples for the training and another one for the validation of the map. But there is a different topic when you are also talking about how to report that in terms of area, which that training that is in the slides is going to help you as well. That's I just wanted to briefly mention that, but everything that you mentioned is very feasible to do. But obviously, how to support it, I will leave to Jeff that in our role of how to keep supporting following up work as a result of this training. But we are very happy of that in these 2 days you already did so much. You definitely learn and apply it already. And hearing the ideas is great. Thanks.
Yeah. And let's see, maybe I can add a little. So there are also more sophisticated ways of creating the classification. So let's see. What we did today was you said, I have some points and I don't know anything else about the world except for these points. So please tell me what's the best fit of the data to these points. And so in a way that forgets what we already know about the landscape. So the algorithm that I have is designed to take the initial estimation of a landscape, maybe your 2016 map, and then add in new information onto it and look for places that change. So that allows us to start with a prior estimate. So it uses Bayesian statistics. So if you know the words of Bayesian, they say there's a prior belief about a system, and then you add evidence onto the system. In this case, the prior belief probably would be your 2016 map. Then we have a whole bunch of images sitting here. You have some training for those images. And so we would train those images with the prior estimate of what the 2016 map is in order to look for places that change. That will tend to give you a time series that's consistent instead of making a new picture every single time. There's a lot of variability and randomness that happens with a new image because the day is a little bright, this other day is a little bit dark. And so that's the thing that we focus on in my lab a lot. That's like our big thing that we're really interested in. So I think especially for the type of problem that you're describing, I like that kind of problem a lot. You've got an older map, you want to update it to a newer map, plus you have some information to inform what the classes are. So it seems pretty neat and something that maybe we look at together.
Ok, muchísimas gracias por la retroalimentación de estas posibles, de estas metodologías que mencionan y de que obviamente hay algoritmos más sofisticados. Nosotros, Marco en especial y la ingeniera Carmen Meneses, que es la encargada de datos de actividad, y en general en la unidad técnica se ha hecho un esfuerzo por crear mapas de cambios de cobertura y se ha utilizado el algoritmo CCDC. Y también con el iMathMath. Entonces nosotros hemos generado ya como tal vectores de cambios de cobertura en unas series de tiempo que hemos hecho solamente para 5 estados de la República y se plantea hacerlo a los 32 estados. Obviamente, como ustedes saben, las implicaciones para hacer este tipo de mapas, pues se necesita mucho recurso monetario y humano y especializado más que todo para hacer la detección de cambios. Entonces, nosotros hemos invertido un importante esfuerzo humano en hacer fotointerpretación tal cual de un tiempo 1 contra tiempo 2 en 5 mapas de un solo estado. Esto es en los periodos 2000-2003, 2003-2011, 2011-2014 y 2014-2016. Ahorita ya estamos corriendo 2016-2018, pero pues nos dimos cuenta que lleva muchísimo trabajo especializado y recursos, más de lo que esperábamos. Entonces queremos ver cómo ya lo que tenemos, podemos integrar esta tecnología, esta herramienta con lo que ya tenemos. Ahorita también se ha hecho una malla con Collect Earth y se ha intensificado. Con eso se plantea hacer también lo que mencionabas hace rato, de hacer una estratificación para reducir el error. Bueno, estas son algunas de las metodologías que en México, en especial hablo por lo que es CONAFOR, está utilizando. Pero sí nos interesa cómo hacer algo más operativo también y aprovechar el poder de procesamiento más que todo y de almacenamiento, que también nos vemos limitados también y más en estos tiempos que, como vemos, estamos trabajando en nuestras casas, ¿no? Y no es lo mismo nuestra máquina personal que nuestra máquina que teníamos en la institución muchas veces. Entonces queremos aprovechar el poder de procesamiento de esta herramienta y de almacenamiento, y así como la creación de algunos insumos también para ayudar en la fotoidentificación y fotointerpretación de ya sean muestras o de estas detección de cambios, ¿no? A lo largo de estos periodos que se quieren hacer. Entonces, pues de mi parte yo estoy abierto a si se puede tener alguna otra reunión. Obviamente no está limitado a los que estamos de México, veo que hay de otras partes, pero sí me gustaría tener como una reunión con ustedes para ver si se puede ya hacer algo más operable o hacer un repositorio de algunas ideas que ya tenemos y no sé si después podríamos exponerle lo que hemos hecho para que nos ayuden a mejorar procesos y optimizar, ¿no? Recursos. Y muchas gracias por el taller, estuvo muy objetivo y nos ayudó bastante, y creo que vamos a poner en práctica lo que aprendimos. Y bueno, de mi parte es todo. Muchas gracias a todos. Aquí sigo, escuchándolos.
Okay, well, great. Is my mic on? Yeah. So, well, thanks, Juan Pablo. That's great. I would be really interested in that. Could you maybe say a little more about creating inputs for helping with photo interpretation? I thought that was a neat aspect of what you said, if I understood you right.
Sí, por ejemplo, nosotros cuando generamos los insumos y se reparten entre los especialistas para sus interpretaciones, obviamente se divide en regiones, y muchas veces aunque se utilizan Lanza, también se han generado unas band metric stacks, unos compuestos, pero sí nos gustaría, por ejemplo, utilizar las imágenes y el poder de procesamiento para hacer repositorios. Eso sí lo veo como algo, digamos, a corto plazo que se podría hacer. Repositorios en donde se puede dar solamente como un link o script o un ejecutable al intérprete y que solamente cargue el área de interés y que sobre esa imagen o sobre esa área que va a trabajar durante esa semana o durante ese mes, se le cargue una serie de insumos, digamos como ya pan sharpening, imágenes de algunos sensores. Esto lo tenemos, digamos, ya identificado y de hecho Marco tiene ya algunos hechos, pero por separado, no sé si se pudiera hacer como algo más operativo para cubrir las necesidades de los fotointérpretes a la hora de hacer las clasificaciones entre lo que dijo que es el algoritmo y lo que realmente es, que al final de cuentas, por eso no nos han sustituido las máquinas todavía, porque pues todavía necesitamos afinar con el ojo humano lo que está viendo. Entonces, para eso se necesitan unos insumos pues de mayor calidad, ¿no? Y de varios sensores y pues veo que aquí se puede ajustar las temporalidades también, ya sean obtener compuestos o time-lapse o otras cuestiones que nos pueden ayudar y a identificar cuestiones en fenología, ¿no? También en época seca, época húmeda, que también puede variar. Entonces, más que todo, ver si esto nos puede apoyar en obtención de insumos para el apoyo de la fotoidentificación de la cobertura.
Yo quería responder la pregunta de África. Los puntos son parte del Inventario Nacional Forestal y de Suelos. Son puntos de campo, donde han sido medidos el número de especies, la dasometría, toda la configuración de todos estos puntos, y estamos seguros después que para la fecha en que ocurrió su medición, es cobertura forestal o no, etcétera, etcétera, qué tipo de vegetación es la dominante, por el tipo de especies encontradas en cada uno de los sitios de medición. Es un plot que está formado por 4 subcampos o submuestras y tienen remediciones. De hecho, tenemos información histórica. Desde cada 5 años se revisitan esos sitios y se presentan aquí. Entonces, lo que quizás el riesgo de usar estos puntos de entrenamiento, por ejemplo, si queremos clasificar el año 2020, usando estos puntos, tenemos que estar seguros que el diámetro de copa de la vegetación no ha cambiado, pues, porque usar ese punto de entrenamiento para generar un mapa del 2020, por ejemplo, si cambió su estatus para el 2020, entonces sí estaríamos cometiendo errores importantes en las áreas de entrenamiento. Entonces, lo que tendríamos primero que estar seguros es que los puntos para el periodo que vamos a analizar están actualizados. Pues.
Sí, cabe mencionar que estos puntos son de forma circular con un área de 1 hectárea. Entonces, como menciona la ingeniera Carmen, hay varias mediciones a lo largo de esa hectárea. No solamente es X, Y y Z, es 1 hectárea, tal cual, de forma circular.
Wow, that's great. That's a lot of work. That's a lot of money to do that in the field. 26,600.
In 20, yes.
Yeah, 620.
Well, great. Let me suggest that that we make a plan sometime. Maybe send an email with some dates that work for you to talk. And if you, for me especially, if you have some graphics to show, that just really helps me a lot. So maybe that could be a good next stage for you to show us some of the, what it looks like in practice and in your mind, and your list of different tools and different resources that you have. I think that would be, it seems fun, and it would be a nice meeting to have, I think.
Claro que sí, no sé cómo, bueno, se supone que nosotros salimos el 15 de diciembre de vacaciones, pero no sé cómo estén ustedes su agenda, o yo voy a estar disponible, creo que no voy a salir, pero también depende de mis compañeros, obviamente. Porque yo, sinceramente, mi formación no es de programador, entonces yo sí necesitaría ayuda. Por ejemplo, Marco es el que más sabe sobre esto, César también, bueno, hay varios en la institución que me gustaría también, no sé, después añadir para que ayuden en esto. Nosotros nos encargamos más ya de la cuestión de los mapas, los datos, validación, hacer evaluación y publicación. Ya como tal esto, la programación, pues apenas estoy empezando, pero sí me gusta, está muy bien. ¿Qué les parece si platicamos nosotros como equipo y les enviamos un email con nuestra disponibilidad y con alguna información básica? Nosotros tenemos todo tipo de presentaciones que la ingeniera Carmen ha dado en la FAO incluso. Hay presentaciones de todo tipo, pero solamente creo saber que solamente cuestiones del ínfice y características de los puntos son lo que les interesa. Entonces podemos enviarles alguna información muy básica sobre esto y pues ya vemos su disponibilidad y estaría perfecto agendar una reunión en los próximos días, la próxima semana tal vez. No sé mis compañeros qué dicen.
Sí, totalmente de acuerdo en que nos pongamos primero de acuerdo como equipo, aquí nosotros, y después si tienen posibilidad de apoyarnos, Jeffrey, África, Ryland y pues Mónica, si quisieran aportar para todo este trabajo que se está haciendo aquí en CONAFOR.
Mm-hmm. Okay. Well, I think that sounds great. Let's all be in touch. Seems good.
Ok, pues de mi parte muchísimas gracias a todos y felicidades por el taller. Estamos en contacto.
Muchas gracias.
Muchas gracias por todo. Fue muy buen taller y se desarrolló de manera muy óptima. Gracias.
Thanks again.
Sí, igual, gracias Jeffrey, África, Ryland. Me gustó mucho el curso. Yo no tengo mucha experiencia en todo esto que vi ahora, pero pues creo que tengo el compromiso de avanzar con lo que ya nos han mostrado y lo que nos han dejado documentos que son muy valiosos. Y si me lo permiten, los puedo compartir con compañeros de la misma CONAFOR que estamos en el área. Gracias.
Nos vemos.
Okay.
Hasta
Wonderful.
luego.
Thank you. See you everybody.
Bye bye everyone.
Bye. Thank you. Bye.
Thank you.
Gracias.